So you saw in the previous video how we dealt with x squared, and we've got a formula for working x squared. What we're going to do now, we're going to try and look for a pattern, and we're going to do the same for the cubic. So this is a different function I've got now is y, this time x is to the power 3. So we're going to apply that same process and see if we can come up with a formula for that. And then once we've got that, then you can try and think about patterns. Maths is all about patterns, and we can sequences a series of other things can help us. So the function here is y equals x to the power 3. So if I have a value of x, and again, I'm going to put my black dot on here somewhere. This is my value of x. So the y value is going to be our value of x to the power 3. So this value over here has to be x to the power 3. So that's my first coordinate. I can write it in coordinate form. It's going to be x, and then the y value is going to be x to the power 3. So I'm going to identify this as my first coordinate. I'm going to call this x1, and I'm going to call this y1. Again, just as before, gradient I want is going to be this red line, so we can see that red line. So again, I don't know anything about any values on that red line at all. It's completely random. I don't have no idea, but I do know about the relationship between x and y on this curve. So what I'm going to do, just like last time, I'm going to pick a point here. And use this as my estimate for the gradient. So if we put this on here. The easiest thing to work with. So again, we can see that's an estimate for my gradient. I know the relationship between x and y at the green point, and I know the relationship between x and y at the black point. So that's what I'm going to do. Same process again. I want to find out this value here. Again, what I've done, I've taken this x value and I've increased its length by a certain amount, and that certain amount I'm going to give an arbitrary value of h. So at this point here, the green dot has an x value of just x plus h. So the relationship is to find the y value, I have to cube my x value. X plus h is my x value, so that means along here it's going to be my y value, which is going to be x plus h all to the power of 3 this time. Okay, so now I can put my coordinates of the green dot. So the coordinates are x plus h, and then the y is going to be x plus h all to the power 3. And my coordinates for the green dot are going to be x2, y2. So we're ready now to sort of, again, write our formula down. We know what our formula for gradient is. M is going to equal y2 take away y1 divided by x2 take away x1. Standard formula for that. So substituting the values in, we have y2. y2 is x plus 3 to the power of h. Right, plus h to the power of 3, sorry. Take away y1, and y1 is just x to the power of 3. And that's going to be divided by x2, and x2 is the same as last time. It's just going to be x plus 2. X plus h, sorry. Take away x. So I suggest you do is pause the video, see if you can simplify that function, just like we did before. If you look at what we did before, we expanded x plus h, wrote it down, and see if we could simplify it. So if you end the video, if you end the, to just put it on pause. So what we'll do then, well, now you've had a go at that, we'll expand this x plus h. To power 3. So we could do it by hand, or if you've done this in maths already, we could use Pascal's triangle to do that. Whichever way you want it. So it would have been x to the power 3 plus 3x squared h plus 3x h squared plus h to the power 3. Okay. Again, if you've done Pascal's triangle, then you'll see how that expands and how you don't really have to spend a lot of time working it out. You're just looking for a pattern to expand x plus 3 or 2 terms to n power. So we can fit this into our function now. So now my gradient is going to equal x to the power of 3. Get that 3. X to the power of 3 plus 3x squared h plus 3x h squared plus h to the power 3 minus x to the power 3 all over x plus h minus x. So it's getting a bit long-winded now. But we'll just to see what we can cancel out. Well, I can see the x to the cube cancel out, and I've got a negative x to cube at the other side. I've got an x here, and I've got a minus x here. So we can write the gradient down in a little bit of a simpler form now. So now gradient is going to equal 3x squared h plus 3x h squared plus h to the power 3 all over h. So again, to get a better understanding, we expand it out a little bit more to make it easier to understand where things are going. So we've got 3x squared h, that's divided by 8, and we've got 3x h squared, and that's divided by h, and we've got h cubed, and that's divided by 8. So we've just simplified that a little bit to see where things are going. So first one, I've got h on the top, h on the bottom, so these will just cancel out. I've got h on the bottom, and I've got an h squared on the top, so that will cancel out with that. And I've got h on the bottom, that will cancel out with one of that and make that h squared. So then our gradient now becomes 3x squared plus 3x h plus h squared. So again, if we look at what we've done, because we know the relationship on the graph at that point. To get that curve closer, that straight line, green line closer, what we're going to do, we're going to decrease the value of x. So we want to bring it down to a value of 8 so we get this virtually on top of it. And as we saw before, if we do that, then our green gradient will match our red gradient. So again, now we can write as h approaches 0, then the gradient is going to equal 3x squared. And now we've got a formula for doing 8x to the power of 3. So we need to think about relationships and patterns. So what we've done so far, we have done the first one. We did y equals x squared, and the gradient was equal to 2x. And then we did y equals x to the power of 3, and the gradient was equal to 3x squared. So what I'm going to do is dispense with the m, because that's leading. So the gradient is really change in y divided by the change in x. Change in y divided by the change in x. So now you need to look for some patterns and see where you go from there. See if you can work out, if I had y equal x to the power of 4, what would the gradient be?